Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I'll be sharing another example from the professional engineer exam. In this example, unlike previous exam, you cannot simply take moment equilibrium at point A or point E and find the forces, reaction forces. So in order to find the forces, we can split the frame into part A, B, C and C, D, E to find forces. So we can simply take moment equilibrium at point A and find the reaction forces for A, Y, and AX. Similarly, for the frame CDE, we'll find the forces and we'll take the moment equilibrium. So now we have two equations, two unknown, and from two equations we can find simply the Cy and also the Cx from two equations. And using force equilibrium at horizontal and vertical plane, you can find the other reaction forces at point E. So now we have found the reaction forces. We can draw the reaction diagram. It is convenient to draw the moment diagram based on the reaction forces. We know that we have the 60 and we have a length of 11 meters. So there we have the moment at point B. And based on the theory that the moment is same on the joint here, so there will be also 660 there at point B. And similarly, we have the reaction force 153. We have a height of 4 meters. And then we have also the moment diagram, the moment there. So finding the shear diagram is a bit tricky, not for all part. Here we know it's very straightforward. We have 60 kilonewton shear force there. We also have 153. So these two are very easy to be found from the reaction diagram. But for the B, C, and CD beams, it's a bit tricky. It's not rocket science. So this is the component of the sinus and the cosinus of the reaction forces we already found. So we know those two reaction forces, and we also know the angles. So we have beta and alpha. So beta is 22.6 and alpha is 67.3. So we know that this is the cosinus of both. So here for the beam BC, so these two forces that we found, the components, these are not in one direction, so one will be plus, another will be minus. So then we have a difference, which will be the 50.77 there. Whereas the point C, so those forces from 80 kilonewton and 60 kilonewton acting at the same direction, it will be plus. So that will be 96.92, and that's also in minus. So here we have the force 9 line load, and so this is nothing, just the difference between these two that we already found. So that will be the difference will be 2.77 there. So that was the shear diagram. So for axial, we know also these two reaction forces, 80 and 28. These two are also very straightforward, but again, it will be a bit tricky for the beam BC and CD. This is again the horizontal the component or the axial component along the beam BC. So at this time it will be the sinus of alpha and beta. So now we found the reaction forces, moment, shear, and axial diagram. So now we'll compare our results with the static program to just see if our results correspond with the static program. So this is the same frame and the same laws are applied here, same width and same length. So we'll check here the reaction forces. As you can see, 80, 60, 28, 153. So the reaction forces correspond. To see the moment diagram. Same here, 660, 660, and 612 here. And the shear force, 60, 50.77, 96.92, 2.77. 2.77, 153. And also the axial diagram. 80, 28, 66. So this corresponds with the hand calculation. So here you go, you have all the results. Until next video, have a nice time. Assalamu alaikum wa rahmatullahi wa barakatuh.